the way, we are recording this, and this will be made available. And we want to just thank our partners at NASA for being super good to us over the last 15 years. And we'll talk a little bit about that as well, and what that relationship looks like, and the cutting edge things they've been able to do with open innovation. Just want to thank again my organization, Altruistic, as well, and D-Cube. And by way of introduction, Karim, I'll introduce you first. Karim Lakhani is professor at Harvard Business School. He's also co-founder, chair of little error there, sorry, but Digital Data and Design Institute. And I just want to plug the course here. A lot of our effort at LISH went into developing this course on open innovation, and Karim's featured in it. I'm guest lecturing it as well. And it's a really dynamic course. We've gotten some really good feedback over the last year on the contents. The presentation, the material is fantastic. And just the thing about Karim that some of you may or may not know, but Karim is like an avid supporter of all things fun. So my first memory, early memories of Karim, like when after the time you sent me the JSE, which was like my third day of work, you told me to go to Johnson Space
JSE is what? JSE is the Johnson Space Center. Yes.
Yeah, to figure out the crowdsourcing program, and I was like, I don't even know what crowdsourcing is, so thanks very much. But remember, we used to go on those staff retreats, right? And I remember us riding little duck boats and shooting, and that was fun. So just a little back. But always keeping it kind of cool and casual. So I always appreciate that, and of course your mentorship for all that I do, and just spurring me on to bigger, greater things always. And I'm happy to be here with you today because, again, our favorite topic to talk about, which is open innovation, and then now again with the AI shift, we can get a little bit deeper into the implications of that, right? So I'll turn it back over to you, and you can say a few things about me.
Yeah, so Paik, I'm hating Jin right now because he decided to leave Harvard and started.
I'm still here. Just
new startup. You're still here. I know. You're still here. But Jin is now at Altruistic. We had 12 good years of an amazing collaboration doing research, and rare among Harvard admin staff, he actually has a book based on the research we did together. So it was a true partnership that we did together. And Jin wrote cases, Jin participated in our research projects, and also helped us run our lab. And very, very happy to note that Jin has a book coming out when?
January 2024. So in about...
Okay, so it's around the corner.
Yeah.
All right, on open talent, which works with another good friend of ours, John Windsor.
Yep. And
really leverages all the work that Jin did here with us as well. So again, he was the founding general manager for LISH, the founding head of labs for the Digital Data Design Institute, and now also co-author. And really, I think the success we've had in our research and our enterprise is solely due to because Jin actually got the work done and would make sure that I would show up.
Our teams did really well.
Our teams did all, our teams, But Jin built all the team, so it was great to have that. Anyway, enough about us.
No, one more thing though. When I started, again, I was a little younger. Definitely had a little more hair, so I'm definitely starting to lose a little bit in the back. And
I've lost all my hair.
Old. If we go back to your old picture here, you see that's a nice full.
I have more hair. Yeah. More hair. But I decided to grow a beard instead. Jordi, welcome from Barcelona. Yes, we will be sharing the recording later. Yes, absolutely.
Great.
We're all about open source, so yes, no secrets here.
Yeah. Great. So just a little shift here. Karim, you want to just walk us through a little bit of the timeline of the lab, because we're going to hit some big points and milestones. Again, a lot of this is written in our book as well, but just to set the stage for where you are academically and professionally in your journey when you started to engage with NASA, what that meant for us with the initial platforms that we're working on and the cases and the research you did, and what this actually allowed us to do, again, from both our labs is kind of unique, right? Because it's both, we're studying these things, we're studying the effects of change management, innovation, crowds, but at the same time, we're executing practical deliverables, which we'll talk about with our partnership. So if you want to just kind of briefly run through.
Yeah. Look, I've been so lucky to have this whole enterprise inside of my life. And really, it starts off with, two key people at NASA. One is Jeff Davis. Jeff was in an exec ed class in 2007 or 8, where I presented some of my early stuff on crowdsourcing and on incentive. And Jeff was like, "Oh, we should work together, and you should come give a talk." And the story with Jeff and I is that Jeff gave me his nice business card, and it said, Jeff Davis, director of space life sciences at NASA. And I'm like, okay, whatever. I get
Chief
lots
medical
of
officer, right?
chief medical officer too. Like, I didn't pay attention. I love that. My dream was to be an astronaut way back when. But I ignored Jeff for like 6 months, and then finally Jeff called me. This is in the era where you actually take phone calls, and he said, "Dude, I'm like the head of Space Life Sciences Directorate. I've got 1,500 people working for me, and I keep astronauts alive in space. I need you to come to Johnson Space Center and talk about your research." I'm like, "Oh, okay, I'll come."
Yeah.
Anyway, so Jeff was key, and then also Jason Kruzan was amazing too, because he was the chief technology officer for human exploration at NASA. And they both got interested in crowdsourcing and really got us going. And we started to do some research together. And then they came to me and said, "Hey, why don't you run a lab?" And I'm like, "Lab? Oh, why? Like, I've got my data sets, I've done my research, I'm off." He goes, "No, you want to do more work with you. We want you to help us scale up crowdsourcing at NASA, and then you can also do a lot of research as well." And that was the trigger for the Harvard NASA Tournament Lab that we established in 2009. And since that time, we've just been sort of growing in our footprint and our ability. And then Jin joined us in 2010. No, 2009. You also joined us in
2011. Yeah.
11, yeah. And we started to do research with Harvard Medical School. We advised the U.S. federal government on establishing a Center of Excellence in Collaborative Innovation. This was Tom Khalil in the Obama administration in the Office for Science, Technology, Policy. We went beyond NASA, so we renamed ourselves the Cloud Innovation Lab. And by 2016, we had done over 800 challenges, and we were pioneering in the academic route, field experiments for innovation. And in 2017, right after I got tenure, I got tenure because of Lish and because of the labs. We called ourselves.
We got that on record now.
Yeah, laboratory. Oh, totally. I've always took that. So anyway, that's been the Lish journey. It's always been a community of people that do cool research. Some of the folks are here. Dr. Sergeyev is here, one of our early data scientists before there's a thing called data scientists, and we did really cool projects together. So that was our journey.
Yeah, and we'll talk about this a little bit later on in terms of scaling, again, open innovation, open talent models. This is quite an establishment for NASA as well, right? Because these programs are very hard to scale, and not just the leadership, but just the culture change that was needed, because the studies that we've done have shown that there's massive resistance to this, despite 10x better, 100x better, that kind of thing. And so, but eventually, our good colleague at NASA, Lynn Bucca, who managed the Center of Excellence, she won a service medal for this, right at the 10-year anniversary. So it's a big deal.
And it's very rare for like
a non-technical person,
manager, non-technical people to win a service medal. Yeah.
So along with just the massive support we got, just to be able to see it and advise them, and scaled across the federal government, right? So like, this was not just NASA that we're talking about. We're talking about problems that we did with DoD, HHS, and so on and so forth. That was incredibly powerful. Great. So a little bit here, just the cross section of this. What we did was, for the purposes, I think, of what we wanted to do in terms of objective measurables, but also some of the contest work, because we partnered with a great platform called Top Coder for many years. In these sort of 800 projects that we did a lot of these computational biology, algorithm development challenges, advanced analytics, and so forth. And so research dovetailing with complex problems that we tried to solve. And I like to kind of frame this. I know there's massive talent shortage, and has been for some time. And we're even facing it even now. 42% of executives surveyed by McKinsey indicate talent shortage, especially with AI work and barriers to AI adoption. Korn Ferry report by 2030 here talent deficit of 85 million workers, which is about the population. It's greater than the population of Germany, right? And so the point, I think, is the ambiguity of what talent looks like, and high demand puts managers in difficult positions to get work done. Karim, I want to kind of lay this out because, again, this was a collaboration that we did with Dr. Ava Guinan, Dr. Ray Mack, and Dana Farber and Harvard Medical School. But this will kind of, let's go through the objectives of this, the results of it, and then we'll talk about the theory of this, right? So, why crowds matter, what do they produce, what's extreme values, what's diversity, and that kind of stuff. But if you can lay out the foundation for us, because this was really, we'd done a series of these sort of things. You had done some work with medical school previously, but this was like the first, like, cutting edge achievement when we think about AI algorithms, right, and what their capabilities are, and sort of crowd generated to do fast road prototyping, which is, I think, where the bread and butter is for how we think about using open crowds, right? And so give us a little bit on the context of the problem, and then we'll go through the results, and then we'll talk a little bit about the extreme values that we're seeing.
Yeah, so just as Jen was an amazing collaborator in launching our lab and in really scaling our lab. Ava Guinan, Professor Ava Guinan, who is a radiation oncologist, was my early academic partner. And what's interesting about Ava is that she is curious about the innovation process and how it can help medicine and medical schools and research and so forth. So Ava and I have been collaborating for a long time, almost as long as, with Jen, maybe a bit longer than Jen and I. And so Ava, drank the Kool-Aid about crowdsourcing, and she said, "Look, there's been a lot of work being done on detection of tumors in the body through AI, but very little work being done on the next phase, which is actually the harder phase, which is once tumors are detected, you need to have a radiation therapy plan to go look at the 3D volumetric space of the tumor and design the algorithms that will just target the tumor and not the healthy tissue." So we worked on running a contest to show, is this even possible? Is this too far outside what AI could do? And so we worked with Ray Mack, who's the first author in this paper, and you see Renat's name in there, other folks as well, to really figure out how to run a contest that could solve this problem. So we ran this as a 10-week contest. We had 3 contests embedded inside of this, and some interesting details there. But the results are kind of crazy. We offered $55,000 in prizes. The best solution, which is an ensemble solution of many different algorithms, is basically inside the benchmark of Harvard-trained radiation oncologists. Okay, right. So yeah, and so we're already within, like, with 10 weeks of work through a crowd for $55K, we're already in the right inside of the iterator reliability of how tumors get done inside of leading medical schools. And the ensemble solution that we have is actually better than any commercial benchmark by 30%. Crazy, right? And what we're able to do, and that leads to, so we care about getting these algorithms done, but also getting publications. So here we have a paper in JAMA Oncology, which is a leading medical journal in cancer, probably the top cancer journal in the world. And I'm a co-author on the paper. And the joke I make is like, look, the last time I did biology was in 10th grade, and I got a C. So, but this is the thing of what's happening with AI and with crowds now. You can lower the cost of innovation and speed it up in a radical way. And this is like, evidence of this getting accepted in the peer-reviewed journal about how this works and why it works.
Yeah, and the part about this that, again, that's detailed in the paper, we talk about it quite frequently, is that design of these things is very challenging, right? And as we think about sort of the title of this webinar today, what we're doing in the generative AI era, right? It helps you sort of start to filter through the problems a bit, right? It kind of unlocks the ideas. This is something that we did in conversation, but potentially if you had access to text-to-text work on this or text-to-image work on this, like, we could rapidly start thinking about problem formulation a little bit faster around this, right? And iterate and have ideas. And that's where like the human and the machine component comes in, even prior to launching a contest, right? Like how internal contest organizers or problem owners really start to craft what's a key piece to this type of work. So that's my reflection now, looking at through the lenses of what's happening and how we can move kind of quickly around this. By the way, feel free to ask any questions. We'll try to field them as we go around this. And then
just put them in the chat. Exactly.
Yeah. Shifting this, Karim, this is adopted from some of our work together about probability and the value of an idea and what you're getting with traditional experts versus non-traditional experts. So in the case, what we're not saying in the previous example here is that crowds are always better than these doctors at Harvard, right? Like we would never say that. I don't think that's something we're trying to say, but as a complementary and in the right design, the right incentive structure as a setup, going back to sort of this talent shortage problem, we can leverage these things to help get through these bottleneck issues, right? And this is where we have done a lot of work in thinking about, look, we don't need these grand prizes, right? Because the question I get most frequently is, how could you do this with, 55K? And NASA's got hundreds of these examples where it's on the lower barrier to entry because you want to lower the prizes for a good reason. But the theory behind this is really thinking about your traditional experts versus your non-traditional experts. So you want to walk a little bit, us through that a little bit. That'd be great.
Sure. So one of my big ahas as I started to study open, so I became an academic to study open source software about communities. And then we also saw in the early 2000s, these contests emerge as well. And what was very helpful was the paper by Lakhani and Mendelsohn in Management Science a while back, which sort of talked about innovation as a statistical process. So if you start thinking about innovation as a statistical process, then you go, aha, what matters is that basically you can model it as some kind of a normal distribution of outcomes, right? If you start thinking statistically, you can start to say, there's probably some distribution of outcomes that can be modeled as a normal distribution. You can take any distribution, but normal is always good enough, right? And then the way to think about it is that when we're innovating, what we care about is the extreme value. We don't want the average. So if you do something once and you innovate, you just get the average value. But what you care about is the extreme value. You want the right tail. The right tail is what we care about in innovation processes. In manufacturing processes, we want the average, right? We want the mean and the standard deviation to be super tight. In innovation, we want actually like a pretty broad dispersion, and we got to figure out a way to get to the right tail. So that's what the idea is, that you want the right tail. Now, how do you achieve the right tail? Many different ways to achieve the right tail. You might try to go find the smartest person in the world, and hopefully that when they innovate, they'll be in the right tail. That's one solution. And that's what companies hope to do. But the idea here is that that what crowds allow us to do is to basically get more probabilities of getting the right tail, right? Because we don't know who might have the right answer at the right time, has the right effort, the right knowledge base. So when you open it up, you can basically, and Jen, if you go to the next slide, we can sort of show the story, right? Like you basically have this value of an idea, the average idea. Next slide. And what you care about is this, so the right tail. Now, the way to think about this is that for a company, it'll be very expensive to hire all these people and find the right tail. You might have to go find the right tail person, but it's never guaranteed. They might be having a bad day, right? Yeah. When you go to the crowd, you don't have to pay for effort, you pay for performance. Right. And paying for performance basically allows you to then sort of sample broadly and then bring this into your organization and get the right tail. And that's been our story. Like we have repeatedly shown that we can be cheaper, faster, more effective, better than what elite organizations do, because we can basically open up the right tail cost effectively. And so there's a couple of interesting questions here that I want to address in the chat. One question Jean-Louis asks is about how big should the crowd be? That's a great question, and Todd has a great thing that more than 3 people for sure. Yes. We've done some modeling. I see the paper we need to work on and submit finally or resubmit finally. We're finding, and this is work with Michael Minetti, our research scientist. Michael has, with me, has shown that basically the number is actually like 24, 25. It's not that big actually to get extreme values. Now, there's a whole bunch of assumptions about where the distribution of the company might be, where the distribution of the crowd might be, and so on and so forth. But the numbers aren't as extraordinarily big as what you expect, right? Not in the thousands, maybe sub 100, and you'll statistically you're guaranteed to get this kind of thing. So that's the first thing that Jean-Louis asked. The second question that I want to go respond to. Thomas asked a very good question as well. Is that what about the diversity of the crowd? Absolutely, not the population size. No, of course. Now that is a really good question. What we have sort of seen is that as the N increases, diversity also increases. The question is, how much diversity is enough? And we don't know. And there's some really good work actually by Scott Page. And there's a great paper of Scott Page out of Michigan and Hong Lu wrote about the diversity and what diversity gets for you, and some very excellent modeling. And so openness allows us to bring diverse ideas, and we never know which diverse ideas are going to be the right fit, right? And so this matters quite a bit as well.
So,
go ahead, Jen.
I think there's an important point here. Back to the lung cancer example, the reason why that was in 3 chunks, right? It's 10 weeks, but we did it in phases. Is that you start to get the initial phase was basically code around this, give us your ideas, and then collaborate, right? We'll release them, and then you'll kind of see how people are approaching the problem. And then you start to get more diversity within the solution. So it's just all diverging and then converging. So it's a combination of these contest designs, but also curating communities out of this that want to solve the problems together, right? So initial, what we're talking about rapid prototyping is get this out there. It may fine-tune your problem enough, or in practice, what you start to see is, look, we're not asking quite the right question, right? So like back to our lung cancer example is initially we were like, oh, crowds, find the tumor and then, do the delineation, right? Have your ML algorithm start to figure out how to do the segmentation automatically. And then in reality it was, well, the doctors don't have to, they already know where the tumors are, right? So then they have to do the segmentation around the software on their own. So in some ways, it checks both of your biases and your assumptions, but it kind of gets you to see whether or not you're even asking the proper questions, right? So this formulation is very difficult, but you can do that initial tech. Like so many people that we advise and we talk to about this sort of work, they're like, I don't know if I have the right problem or that, but like you have a lot of data and you have a lot of questions around this. You can start to ideate, and then, or you can just go to the crowd first, right? So I think years past, when you and I have given this presentation, was largely a question is like, should we go to the crowd first to get that initial benchmark, right? So that you can find this tail end first and start to pivot around that, rather than inserting just your own biases of this is the answer, this is what it needs to look like. Then you can kind of get out there. So I think that ends up being interesting.
Absolutely.
Christina here about incentives. I don't have a slide around that we usually do, but do you want to talk about some of the intrinsic pro-social, because that's a big driver, right? There's a reason for that.
100%. And so look, there are two dynamics to think about, right? One is purely the statistical dynamics of this, right? The statistical dynamics are, look, open up, right? Bring in the crowd, and then you get extreme values. And then this crowd size, cognitive diversity, all those things all fit together into that perspective, right? And then, as Jin was saying, we can design sort of convergent and divergent contests, and you might bring in different types of people coming through. But then the second part is like, well, why are people doing all this stuff? So when I started looking at things like open source and Wikipedia, people used to say, oh, works in practice, not in theory. Right. And it's true. Like, when economists in the late 1990s and 2000s started to look at open source, they're like, this makes no freaking sense. Why are people, this should be the classic, commons problem, right? That basically the commons gets overgrazed and nobody has any incentives to put in the seeds to maintain the commons. But we saw the opposite come through, and what we discovered both in open source and in contest, very interestingly, was the same dynamics of incentives. And there are three categories of incentives that we've sort of seen. One are what we call extrinsic incentives. You do this for the outcome. You do it for the prize money. You do it for the solution, and so on and so forth. So people care about that as an extrinsic motivation. The outcome matters to you.
Yeah.
Then there's another set of people that do it for intrinsic motivations. They do it for the fun, the joy, the craziness. And that I never understood that, but apparently people like to debug code. And
yeah, so we had an example of this, right? Where in one of our DNA sequencing problems, we had a guy who never attempted these things, didn't use a library, and it was like, I just wanted to know because I don't have an opportunity to compete my skills on these sort of things. Like I kind of know when to rank. It did happen, he finished first, but it's an opportunity. And so when NASA releases a problem, that's also interesting, right? Like I kind of want to spend my life, solving something for space or working for NASA, and there's a whole diverse group of people out there that are just like, look, the 3K prizes, it is what it is. It's great, but there's something inside of us that says, look, we want to be able to do this and make a contribution.
Exactly. So people might exactly. I'm trying to do it for a good cause. I'm trying to do it because I enjoy it. But you'll be surprised, and this is the thing that like people love. There is if you go to Wikipedia, there's a bunch of grammar nerds on Wikipedia that just like to go in and fix grammar in Wikipedia. There's a bunch of, and all of OpenAI is trained off of Wikipedia because the grammar is really good, and because the grammar nerds have gone in and fixed all the grammar, right? That's the whole thing with software bugs and so forth that people do as well. So you never know what the idiosyncratic preferences for activities are by people. And guess what? You don't have to worry about it because you can just open it up and people self-select. And the third bit is what we call pro-social motivations. You do it for your sense of belonging, for your sense of identity, for a sense of community. So these three things we see as being important. And these things they're not substitutes, they can be complements. But what we see is that different people at different stages of their lives on the different problems get motivated by either extrinsic, intrinsic, or pro-social motivations. If you sit back and just reflect back on your own lives and the choices you make to do different kinds of things at different times, you also will be able to have an explanation as to why you do certain things. Why certain things you might do for no money, certain things you might do for fun, certain things you do it for identification purposes. And this is the nice thing, that this actually fits together in this way. And so it's a rational explanation as to why the crowds work the way they do and why they're so effective. And one more component. So again, we talked about structurally, right? Statistics. We talked about, from Christina's question, incentives and motivations. The third bit, which is equally as important, is self-selection. Self-selection. Here's what happens, right? So I don't have to, my boss doesn't tell me, go work on this problem, right? Two things are going on. You're self-selecting based on your knowledge. Oh, I might have a shot at this problem. Let me go take a shot. I don't know who you are, but the person themselves self-selects on the knowledge, and they self-select on their motivation. So these three elements, okay, statistics, extreme values, normal distributions, okay? Secondly, incentives and motivations. And the third thing is self-selection. These three things come together to give us these kinds of outside kind of a setup.
One more highlight on that, the research coming out of the lab, which I thought was great. It's Olivia Jung and Yana Gallus did this, right, with us, internal innovation as well, right? Internally,
yes,
outsourced contributions to problem. And we're finding there was that managerial recognition is great, right? In a cashless society, in a cashless open innovation pool, the contribution is managerial recognition, right? And there's so much to say to that look, there's a lot of people out there that'd be willing to do this for a shot at doing something at NASA or getting some recognition. But if we're thinking of in the context of an organization, and of course cash is king, but don't underestimate that you have to recognize the person, right? And we saw this in some of the cultural battles as well as NASA was scaling, that you got to recognize the people solving the problem, but you also have to recognize the people bringing the problem, because they're the ones who are taking the deep dive, right? To say, hey, I'm really good at what I do, but this one I need a little help on. And that's threatening, right? That's threatening for a NASA scientist to come out and say those things. And you do have to address that from a management perspective.
Yeah. Hey, Jin, I want to give a shout out to Arnav Ajna, because Arnav is the 8th grader who's here in
Nice.
this call.
Awesome.
Amazing. Welcome, Arnav. I'm glad
Great
that you're
age.
investing in your learning at this level and not afraid to ask questions. Amazing.
And compete in a lot of junior contests. We have a lot of those kind of things. Well, all right. So shifting here to our colleagues at NASA, again, going back on this, right? 2005, this is with Dr. Jeff Davis. 45% of the research and technology development budgets reduced, and it's calling for new innovative methods. Went through the story early on, and then Jeff kind of reaches out to you. One of the problems that I love, this is the first one that I think we solved. Kind of that was our flagship, right? It had been on the table for some time.
We solved a bunch of problems, but this was the
This
this is
was
why
pretty
we hired
cool.
this is why we hired Renat.
Yeah, this is why we had Dr. Renat Sagiv, we had Dr. Michael Andres, two quantum physicists working for us, right? On this sort of thing for a long time. And this one's pretty cool because I found that picture, that t-shirt there. So this is interesting, right? Like for 30K, but then everybody got t-shirts out of it, right? So that's another kind of bonus kind of thing. But
Well, yeah, teachers win get us lots of contestants.
it does, yeah. So it drives it up. But essentially the problem here is optimization of solar energy, right? So the Londron has are these big arms, and depending on the rotation and the revolution around its positioning of the Earth and where the sun is, you get massive overshadowing, and then it causes damage and breakage and so forth. And this, I believe, when it was first flagged to us, $1 million problem, right? $1 million problem that
Easily.
literally solving on spreadsheets, if I
Yes.
recall. And we worked very extensively with Viper, the space station manager, on trying to get these models going and working it. And the results of this are pretty fascinating as well. Again, another thing here, 30K prize purse, distribution you see there, where we had 459 participants, over 2,100 submissions. Algorithm actually performs better on edge cases, and it's comparable to current tools, right? So another fast thing. And I always like this where country of participation, right? So you got Italy, China, Poland, China, Russia, China, Canada, China. So again, that geographic diversity that we see around this. And then this is where, like, going back to sort of the value of an idea, right? So you're getting all these submissions, right? You're getting every single thing that you see here, and some will fail. So some are not certainly going to be useful in many ways. But these objective sort of contests are interesting because you set the benchmark at the beginning. You set some criteria, you recruit judges. In this case, there were no judges, but in ideation, we think about that, right? You want to have these things beforehand. And then what you see is, oh, all these competitors, 110 of them above the benchmark, which is pretty incredible in a short period of time, right? And this is elite institutions we're measuring against this. Anything else on this one, Karim?
No, I think this is exactly right. And if you go back to the crowds, the distribution slide, I want to respond to Todd's question. Todd also said, like, there's a large churn rate. I think that's by design, because of self-selection, if somehow for whatever reason it doesn't fit for you, it's fine. You can move on, right? And so if you imagine, the 390 contestants, we gave prizes to the top 10, right?
That's right.
Those 10 will probably come back. Maybe the next 50 might come back as well, but the rest will churn out, which is okay, fine, because again, you don't want to. The whole idea is self-selection matters, and the challenge for a platform is to make sure that there's a steady stream of contests that are available to the participants to work on, and some do it for their own learning, some do it for their own fun, all that kind of stuff, and you just make sure that that is happening, and then this is a derivative byproduct of people having fun. You basically get cool solutions coming through.
Yeah.
No, Todd, I don't think it's a sucker born every minute. I think it's really like, if I'm enjoying myself and I say, oh, am I good or not? This comes through. You're very pessimistic, Todd. Oh, and I want to talk about Renat. Renat said, yeah, on this first interview, I didn't remember asking him, so how would you solve the solar panel challenge at the International Space Stations? And oh yeah, also we need to figure out how to detect earthquakes early. Small problem.
Cancer, Space station, earthquakes, the hunt for Genghis Khan's tomb. That was
Yes. Oh yeah.
yeah.
I forgot about that.
Chapter 6 of my book, I detail that, so it's good.
National. I totally forgot about it. Oh my God, we've done so many crazy things.
Yeah,
Amazing.
a lot of fun. Illegal fishing was another one that we did,
Yes.
and so on and so forth. So it's a lot of good. It's cross cutting, right, across domains. I don't think it's and largely we're showcasing these AI based contests and some ideation here because we were a lab, we were able to do that, and the objective measurements are key, right, in terms of publishing academically and so forth, so we can show performance, but wide variety of things at these
We're not just listing other things we've done. We did atrocity prevention work with a nonprofit funded by USAID, deep transmission network in the space.
Space protocol. Yeah, at one point that entire group, the disruptive technology, they were doing, because it's space protocols, emails and texts and images and videos back and forth.
Facebook in space. Yes.
But they at one point they were 100% using crowd mechanism in their shop, right? So it's pretty powerful.
We identified some moons and Saturn rings, and also did asteroid detection. So we had so much fun. It was great.
That's right. All right, and then this is another one, again, pivoting away from some of the algorithm stuff, but Space Poop Challenge, this was wild. That happened a few years back, and again, 20,000 competitors all around this. Like, what do you do with waste, right? What do you do with human waste as astronauts collect them? A problem that's not easily solvable, because as you can imagine, you're in a spacesuit. You have to go, and how do you collect that, and all sorts of things. Interestingly enough, thoracic surgeon looked at this problem.
Can you go back to the first slide again?
Yeah.
I just want to say, like, look, this is like an amazingly fun challenge. Again, this is the fun we had at NASA, right? Where they come up with space poop is a problem as we put people on space, and you don't think about it. You think, well, astronauts just go on space, but they got to poop. Who's going to handle the poop, right? And just think, like, 20,000 people got interested in space poop. Who would have known that space poop?
300,000 people saw the page, and this is not something. This isn't a grand challenge, right? Like, we weren't building up to it. This was like, hey, we have this thing. It's coming through the NASA tournament lab. We'll advertise it. So it's pretty cool.
Yeah, exactly.
Yeah. And the results of this, again, and I think the key here is, again, sometimes it's cognitive surplus. Sometimes it's just people want to get themselves out there, and people sometimes can see the problem in a way that they haven't done before. And so this is 3 teams here, or three placements here, including different techniques. That second place, I think they were college friends, wanted to get together and do this, and you see kind of like a more of a diaper type thing, and then some existing techniques as well that's being repurposed. And I believe the first place winner actually ended up being on contract with them, and so it's a sourcing mechanism as to we did this when the earthquake challenge that we did as well, where we have all that data, and then find these really killer data scientists through contest mechanism, and they ended up working for the company. So lots of different interesting ways to think about this. I do want to kind of shift here, Karim, and as we think about this, we'll get a little bit more back into the contest and how organizations think about it. But like how would generative AI help us with this sort of thing, right? Like, I think this is like, if we were to launch this now, how do we think about this?
Yeah. So let me actually show you. Let me see if I can find this. Yes. So I think generative AI is very interesting in this context, and the way I think about this is that it's really the way to think about this is it's really a lowering the cost of cognition for people. And if you believe that, that has some pretty profound implications. So I'm just going to take over the slideshow for a second, and I'm going to show a couple of quick slides on this. So the way to think about this is the following. I'm going to share my screen. There we go. Okay, you guys can see this, right? Great. So again, we talked about the normal distribution, right? And we talked about extreme values.
Can we see it? I don't know if everybody can see it.
Oh, you can't see my screen?
I have to stop share. How about that?
We see it.
Okay, all right. You took over. Okay, all right. So yeah. So we talked about this, right? Extreme values, normal distribution, and so forth. And if you imagine that the cost of cognition is going to drop, and people will then get boosted by AI, what might that look like? So this is basically the thing we expect, right? We expect a right shift in performance, okay, for people. And interestingly enough, the left tail is going to get cut off, because basically you're going to be, if the orange graph is the graph of AI performance, right? Then basically everybody will be at the average of AI performance, right? Which will be the center. And the left tail basically of the red distribution, of the green distribution, and whatever the orange distribution gets cut off, right? Which is kind of crazy, right? And so what we expect, what this does is that there'll be replacement, there'll be augmentation, and there'll be transformation. And I want to show you something. This slide, we're gonna have this paper out soon. Don't tweet it. Don't do anything with this. This is coming out soon. This is showing you in a setting of knowledge workers what happens when you provide ChatGPT for ideation tasks. And what you see is, you see the control group without ChatGPT. These are elite workers. Okay, there's about 200 people in this experiment, and what you see is the right shift, exactly as predicted. Right, elite workers getting better with GPT, and GPT with, and give them a bit of prompt engineering training, they even do better. So it's for crowdsourcing, this is a massive boost, right? And of course, we want every crowdsourcing person and every crowdsourcing company to integrate, right, generative AI as part of the ideation process, right? And you want the different people to hit it in different ways to come up with different solutions. We have some initial concerns about, are the ideas going to look the same? It looks that to be from our study. We'll talk about that a bit. The paper should be out in the next few days or so. But then the way you might solve that is by having multiple large language models that are diversity trained to help you along the way as well.
So this brings up an interesting point, right? Because this is conversations I've had with some of our clients at Altruistic and so forth. But like the idea that there's some inherent risk to IP exposure, when you're using generative AI, open tools that are out there like ChatGPT. But to have your own language model, that gets interesting, right? Where you have interfaces with both your private data, right? So, and this can be anything, right? Text to text type stuff, where it's manuals or logs of things that you can drop into a language model, train it, program it to learn it. And this is not new. Like natural language processing has been around since World War II, and now it's just being calibrated much quickly. But the idea that the worker, because you talked a little bit about augmentation, the worker can actually access things that potentially they weren't able to before. And it's changing functions, really. It's changing skill, right? Rather than replacement altogether. Because that's far out. It's not overnight, oh, that's going to happen. But the people who are learning how to prompt now and using tools that improve prompting skills and so forth are the ones actually learning how to do these things, both from a query function, like where is this information within my organization? It's there. McKinsey's come out with Lily and so forth for their consultants, and other people are starting to do this, right? Develop language models, but then it's still the skill, right? And it's the coaching of the skill that you need, where you're cognitively thinking about, like, how do I properly ask the question so that systematically I get the answers, and then you start to compare those things with other people, right? Like, yeah, I am a prompt engineer who does this versus somebody else does that, and then you get some of that divergence. And then
exactly,
everybody's getting the same answer. So
I would say, yeah, exactly. So I would say
a query, and then there's a creative function, right? Which is I'm creating things, and I think in the marketplace people are a little bit confused about all that kind of stuff, right? Like, because there's so much power to it, but you can have it at your fingertips, but it's still a skill thing that you have to learn to do. Much similar to the way we used to craft problems, like Renat and Mike would do. That's a skill based on how they see the data and what the asks are, right? And yes, you're able to do that now without having technical skills whatsoever, and with certain types of training programs.
No, exactly. So I expect like there's three things to sort of think about, right? One is for the worker, get good at prompting, understand how the different systems work, right? And your best friend is YouTube. I can't tell you how many hours I've burned on YouTube watching prompt engineering videos. They're awesome. People do an amazing job. And to talk about incentives, like they're creating these high quality videos for free, and you get like a master's degree in prompt engineering easily on YouTube. So go do that. Everybody should be doing that. I tell all my faculty colleagues, go spend time on YouTube, learn about prompting. The second thing is for companies, the way to think about this is that you need to you can't just rely on the generic open AI models or generic Llama or generic Claude. Right. You need to be able to take your data and fine tune it through that. And the third bit is that you want a diversity of models. Don't get stuck on one model. You might want lots of additional models. I'm part of Mozilla. I'm on the board of directors for Mozilla Corporation. The foundation has just spun out Mozilla.ai, and our job is to help create personalized large language models and create the infrastructure for personalized large language models that can happen. So there's a Karim bot that understands me, can reads up all my stuff, and can participate. Can I add one more thing, Jin, on this? How did we get into this AI business in the first place, right? And it was through crowdsourcing, right? So when we started to do our contest with NASA and with the medical school in the early days, right, we were getting early machine learning solutions in 2010, 11, 12, 13. And those were the ones that were being blowing away all the traditional experts, right? So that was the introduction to us to say, oh, this AI thing, this machine learning thing looks to be real, because everybody was basically doing that at scale for us. And that's what got both myself and Jin and our entire lab down the rabbit hole of understanding how machine learning systems were working, what they were doing. And, I'm an engineer by undergrad, but I haven't touched, calculus in a long time. And I learned to program in Fortran, right? And so, so not a good coder, not a good math person. So I ended up being a management professor, and my PhD is in management. But the point is that it was the exposure to crowds and seeing the diversity of solutions being produced that prompted us to go into this AI space as well.
Yeah. Yeah, and on the previous point as well, again, some of the stuff that I've been working on with Altruistic, we actually have ways to refine prompts and get that out there as a commercial model.
Yeah.
We're calling it prompt pilot.
And Alexander Staub is an amazing question. I think TBD. We're trying to see if, in fact, is crowdsourcing dead? I don't think it is, but I think crowdsourcing can be a big. AI would be a big booster for crowdsourcing, and we might be able to get more problems out there and get the diversity of people to prompt in different ways for interesting ideas. But we can be we were fast already. I bet you will be even faster now, right?
And I think it's largely surrounded around, again, organizations and their ability to build language models and providing access to those, right? So it may, because the thing about open, there's also selective open is kind of what I call it, which is it's invitational, right? Like you've got obfuscated data, you have some things that you can hand to people in a black box, and then you can test their skills and then invite them to a much larger thing, right? And so the sort of wave of engaging with work is going to change, but the skills that are necessary to survive, right, and contribute, I think have gotten much more easily accessible, right? So the future of a digital worker is no longer just like, I need to be a data science guru. I think in many ways, that translator function that we've kind of fine-tuned as well, people who speak data, who could work with it and understand and have that business acumen, it got a lot faster, it got a lot easier. But the same thing again on the creation, the ideation stuff is pretty cool.
Yeah. So, hey, Jin, we have 8 minutes left. How should we use our time? Should we take more questions from?
I think we should take more questions. We have some other things, but just to cap off the NASA story again on our end, they massively scaled now.
Yeah, maybe show the slides. Maybe just
why don't you take this question while I bring the presentation back up?
Yeah. Any other questions? Just please use the chat, and then we'll see if we can answer your hard questions. What ideas do you have to well, what to do next that hasn't been tried yet. Oh, you know, I always ask ChatGPT, what should my next study be now? It's great. It gives me abstracts for papers I haven't written yet that I should be writing. It's quite you know, I put in all my papers and I ask it to help me. No, so I mean, I think there's a lot more to be done. I think this, you know, with Jackie Lane, who was a postdoc at our institute, she and I are collaborating on, you know, looking at contests and seeing how AI can help contests. We spend a lot of time also thinking about evaluation, and both human evaluation, biases in evaluation, and then also how AI can help us with that as well. And so it's been really fun to now think about the productivity boost that AI will provide to crowdsourcing, and then think through what does that mean, and what kind of workers can come in, you know, what kind of incentives we need now, and how does this machine AI collaboration actually work?
Just a couple of minutes on this. That picture there, I found this picture the other day. That was a board on a paper that you and I
That's
started.
my writing. Jesus.
Yeah, with Jeff and Elizabeth. We whiteboarded kind of how the whole NASA experience went, which turned into a paper, which is now effectively turned into a book for myself and John Windsor. But it's assess your organization's capabilities around this, learn, right, do workshops, experiment. That's what we talked about with NASA, and then build your capabilities, scale it to a center of excellence, and then you have an operational function like NASA that's made it through several administrations, and they upped the ceiling 5x, right? So went from 20 mil to quite a bit larger, over 150 mil in terms of their capacity. And then just to show that in 2015, you know, you've got NASA Tournament Lab that runs this with these platforms. And they have an internal challenge platform. They've got data science and research, which we did, and then some gig platforms as well. Wild success, right? 40% of the problems are solved, 20% advanced solutions, 34% incrementally advanced, and only 6% there was like no value, 84% where the solutions are implemented, and massive cost savings, right? Almost 250K per project in cost savings, and almost 23 million, of course, from the start to 2015. And then just the scale, which I like here. Whoops, sorry. There we go. Just not how it's even evolved then, right? So this is how you want to think about it kind of programmatically when it comes to this. All right, I think we have 4 minutes left. Any other questions, just to top things off?
Oh, so Victor's a great question. How do the rights of ownership work out? And so Victor, on this side, it's really all about property rights that you set in your contracts. So we've done things with private companies where all the solutions that they paid for became property of the private company, and they can do whatever they want to do with them. And then we did things that were completely open source as well. So those are well-solved problems, and the answer is contracts. You decide with your IP attorneys what you want to reveal, what you don't want to reveal, and then the platforms are more than happy to sort of to provide that.
Yeah, and you're brokering that, right? So you can, you know, you mentioned this very early on in our talk today, Karim. You can pay for performance, meaning you can always wild card and buy all the solutions, right? If you like them, you don't have to just buy the top 5. That's the initial rule setting, but you can do that. And then one of the things actually generative AI can help you do is you can then start to collect a library of these things and then mine them, right? So as you're doing this internally within your organization, or if you've got solutions you've paid for and you have the contract, you own the IP to them, you can then essentially start building a library of these things that you can sort of mine the ideas, and other people can take advantage of more than one contest.
Great. So, hey, Jin, can I just share my so you know, we're almost at time. I want to do a little pitch for the course that we've done as part of our lab, and not so much so you take the course. Well, you should take the course, but I think, Jin, if you stop the share, I'll take over for a sec. I think this course that we did during the pandemic, there's lots of masking behind the scenes here, is really set up to give you a deep dive into the practice of open innovation from all types, crowds, contests, communities, platforms. We have incredible guests, both practitioners, problem solvers, and academics. The who's who, all my friends and all my mentors are here on this course, and it starts. This one starts in October, and I think I can proudly say that the NPS on this is super high. I think it's the highest NPS score in the Harvard Online Catalog. It's good. That doesn't mean that the average is really low. It's actually reasonably high. We're higher than that, and so if some of you are interested, especially the platforms that are here, oftentimes, Trisha asked this question, like, how do I convince people to use this? It's really what we find is that you have to educate the corporate clients so much on this stuff, and it's hit or miss. And so part of the reason why we created this course, and really I want to give a shout out to Nina Cajores, who's not here, is now helping us run labs at DCube.
Stephen Randazzo.
Stephen Randazzo, who is also left us and is now at University of Warwick, working with my former doctoral student Hila. So they really helped create the course. But the course really is designed to give you a deep dive, but super practical as well, and people will immediately see where things fit together and so forth. So I encourage you all to consider taking it. Initially, it was like priced at like $1,800, and we twisted their arms and got it to less than $1,000. And I think they also offer scholarships to people and so forth as well. So I really encourage you guys to take that. Then Jin's book is going to come out in January. We're going to have a big launch event. We should have a big contest, Jin, for your book or something.
Yeah, we'll do something fun. I'm always grateful, right? Like
I know what we'll do. Let's if you can release the full text of your book, we can then put in ChatGPT and create all the tweets and summaries.
I'm happy to do that as an avid open source person, but I think publisher,
the president and fellows of Harvard University will get mad at you. Yes. Because he is publishing the book through HBR Press, which is ultimately owns everything through the president and fellows of Harvard University. So hey, thank you so much, everybody. I do want to also shout out to Kate and Andrea from our team. They really helped us get here.
Thank you.
Thanks so much.
And Brian
for that. And then, of course, Brian, who's in the shadows, made sure that we could actually deliver on this as well. Brian is our chief marketing officer or something at DQ. So really is making sure that we have a great presence. We will release the recording of this, and then Brian will do his magic and create many snippets on YouTube. And we hope that you promote this on YouTube and on all the channels as well. Thank you, everybody. It was wonderful to see everybody and seeing old friends as well.
That was fun, Karim. Thanks.
Yeah. Take care, Jin. And stay in touch with us. Okay, guys? Take good care. Stay cool.